Okay, this little recording is on acid-base balance. And so we're going to deal with pH, buffers, and the respiratory system, things like that. And so here's a little kind of warning signs of acids, because acids are the bigger problem here. And then a pH scale, um, showing pure water at 7, strong acids are have low pHs. Strong bases have very high pHs, like 14. And really, acid-base balance is kind of a special. These are electrolytes, and so it's kind of a special case of electrolytes. But here, metabolism, ingestion is an issue, but metabolism is a big issue. And then we have some additional ways to add to this balance. So we're not limited just to altering the urine, although we do that, but we have some additional ways to get rid of acids and bases. So, first, again, what is an acid? Well, acids are substances, when you put them in water, they dissolve into cations and anions, but in this case, the cation is a hydrogen ion. And this is important because hydrogen ions are extremely reactive. And so they can glom on to a lot of other stuff and cause damage. Um, and so pH is just a measure of hydrogen ion concentration. pH is the negative log of the concentration of hydrogen ions. So what does that mean? I have no idea. But like a strong acid, like hydrochloric acid, has a pH of 1. And what that really means is that the hydrogen ion concentration is there's one hydrogen ion for every 10 other types of molecules in solution. Okay, and so that concentration, 1 over 10, is 10 to the same as saying 10 to the minus 1, where minus 1 is the log. And so if pH is the negative log, that tells you, okay, it's a pH of 1. Remember, neutral solutions have a pH of 7. That's pure water. And so that's 1 out of every 10 million water molecules will dissociate into a hydrogen ion and then an OH or hydroxide ions. Okay, and so that's a balanced solution. And those things will eventually run into each other, and that doesn't affect the quality of the solution much. Substances that are strong bases have the ability to absorb hydrogen ions. And so here, hydrogen ion concentration is very, very low. So it equals 1 out of every 100 trillion, I think it is, molecules in solution. Okay, and that's with 14 zeros, so that's 10 to the minus 14. And so this would be like sodium hydroxide, drain cleaner, has a pH of 14. Okay, strong bases are also bad. Okay, drain cleaner is called drain cleaner because it will chew through anything. And so all the gunk and hair and oil that may clog a drain, if you put sodium hydroxide in it, that those OH ions will just rip through it and tear it apart. And so we want to have our body fluids close to a neutral pH. Any release of lots of acid or lots of base is bad. Okay, and our primary way of dealing with this are chemical buffers. These convert strong acids or strong bases to weaker ones. There are 3 buffer systems: the proteins, the bicarbonate system, and then the phosphate system. So on top shows the phosphate system, where here you have a strong acid, hydrochloric acid, HCl, and then it can react with sodium hypophosphate. Okay, when it does, the hydrogen ion will glom onto this, and this will become NH2PO4. And what will happen is that hydrogen ion here will be attached to that, and then the chloride will form salt. So here you had a strong acid react with a weak base to produce a weak acid. Okay, will hardly ever release its hydrogen ion. And same if we had a strong base, sodium hydroxide. Okay, that releases all the OH ions, but they can react with that sodium dihydrogen phosphate, And that hydrogen ion from there will react with this OH here to produce water, and then disodium hydrogen phosphate will be produced. Okay, so that's how chemical buffers work. They're just big piles of these weak bases and weak acids that can react with strong bases and strong acids. And perhaps the most abundant one that we have is the bicarbonate one. And here, if you have a strong acid, it can react with sodium bicarbonate, and that hydrogen ion will wind up glomming onto this bicarbonate to form carbonic acid, which is a weak acid, and then salt again. And then if you have a strong base, that can react with carbonic acid to produce sodium bicarbonate. And so again, this is how it works. These buffer systems help our body resist changes in pH, and the buffer does that very quickly. And we also have some other ones. Proteins can do this, ammonia buffers can do this. It's very, very effective. It works quickly because these things are always present in our blood. The problem is, though, it has a limited capacity. So if we're typically generating lots of this stuff, it's a problem. So we also have a respiratory mechanism, and this partly uses that bicarbonate buffer. And so when we have lots of acids in there, that stimulates the brain to start increasing the rate of respiration. Okay, and that drives hydrogen ions off of the carbonic acid, and so we get rid of CO2. So we get rid of this weak acid, and that will rise pH, cause pH to rise. So we're restored. Likewise, if we have a lot of alkalosis, OH, not enough hydrogen ions, that will decrease respiration rate, allowing CO2 to rise, creating more carbonic acid and bringing pH down. Okay. Again, there's a limited capacity to do this. There's a limited rate, and you can't do this forever, but it can help you get rid of acids or counteract alkaline stuff. And so this is carbon dioxide, kind of this reaction being used by us, causing the respiratory center to affect breathing rate. Okay. We also have a renal buffer. Okay, and the renal buffer is again uses bicarbonate, and can generate bicarbonate. And so the lining of the nephron can take carbonic acid out of the blood and secrete it into the renal tubules, and so allow that to then react with um, uh, bicarbonate that's in there, and this can then be again used to kind of regenerate this system. So this can help us get rid of acids. Okay. Next time I'm gonna talk a little bit about acidosis and alkalosis, but there are acid-base disorders, um, and there are if we ingest the wrong foods or wrong medicines or in the wrong amount, we often can generate acidosis. If metabolism is altered, like say in diabetes, uncontrolled diabetes, we generate acidosis. And so the acidosis is a problem we'll talk about. And we can also have alkalosis, and this can be caused by changes to the respiratory system or loss of acids through vomiting and stomach loss because of loss of stomach acid. So we can generate that either way. But these are major topics. So I'm going to stop there. We'll go over these a little bit on Monday and talk about reviewing for the exam.